Again, my recommendation is to write the sum down. Let's do that. Limit n goes to infinity. The sum, I'm going to say I equals 1 up to n. Let's look what's changing over here. And, I got 1 pi, 2 pi, 3 pi, up to n pi. Looks relatively simple the way it's written. So let's write this over here. 1 over n times the sign, and it looks like I pi over n. All right? And then the question comes is, what's the length of the interval? And looking at it, it's 1. It's right over here. It goes from 0 to 1, all right? So let's write that down. I'm going to say 0 to 1. And then what's the function? It looks like sine of pi x. Again, it's easy to state something that's not true, especially when it comes to these problems over here. So I want to kind of draw the picture of that and what it looks like to me. It would look like, let's see, if it's sine pi x, it's going to look like this over here. Let me just see if I said that right. So we're starting at 0. Sine of 0 would be 0. And I gotta be careful now. So the sine of pi is, this is okay. So this is what it looks like over here. And let's put a Riemann sum down. And again, this is the function f of x equals sine of pi x. And it's 0 to 1. All right? So what do? Well, each base, equal base, I'm doing the right endpoint, and it's going to be sine. Well, the first one I move over a little bit, and that's going to be what? Pi times 1 over n, so pi over n. What's the next one going to be? 1 over n sine. I move over 2 of those things, so it's going to be 2 pi over n. Yeah, I'm getting what I want. Can I do that integration? I can, and let's go through that. And what do you get there? It's going to be, let's see, minus cosine of pi x over pi, and that goes from 0 to 1. What do you get over here? Minus cosine of pi over pi, minus a minus, which is plus cosine of 0 over pi. I'm going to evaluate these guys over here. Sorry about that. And what do you get over there? Well, cosine of pi is minus 1, so it's going to be 1 over pi, plus cosine of 0 is 1, and it's going to be 1 over pi. What do you get? 2 over pi. Again, what's the question? This. Did I do that? Let's see. Over here. Whoops, sorry about that. I got that written down. I'll talk about the other form of it, by the way, in a second. And I did the evaluation. All right, I got this over here. Let me talk about how to get the other form of it, though. And that might seem a little strange to you, but you could do the other form of it. And I like to do it by use substitution. So I'm going to say 0 to 1 sine pi x dx. I'm going to let u equal pi x. That means du is equal to pi dx. Let's make this substitution. Well, if x is 0, u would be 0. And if x is 1, u would be pi. You would get sine of u. And what's dx? Dx looks like du over pi. Let me just write a little bit differently. 1 over pi, 0 to pi, sine of u, du. You can certainly go back to the land of x's now and write it down a little bit differently. So this integral over here can also be written as 1 over pi, 0 to pi, sine of x dx. They're all the same. Is that written down for you? It is. It's written over here. Oops, I did that again, didn't I? Okay, we're good to go on to the next question. Thank you.